Good evening, students. In today's class, we are going to discuss about alcohols, nomenclature and isomerism. In the previous lecture, we have discussed about classification, and when it comes to the nomenclature, there are three types of nomenclature. Usually, we will study about common as well as IUPAC nomenclature, but in these alcohols, we also have carbonyl system. Let us see what is meant by carbonyl system of nomenclature. See here, methyl alcohol derivatives are studied under carbonyl system. So let us see what is carbonyl. So methyl alcohol or methanol is known as carbonyl. So in this compound, we are going to replace the hydrogens and write the nomenclature. So let us see the first one. If this hydrogen is replaced with a methyl group, the structure of methyl alcohol is as it is, wherein the hydrogen is replaced with the methyl, and we name it as methyl carbonyl. So very simple system of nomenclature where in the carbonyl hydrogen is replaced with the methyl, so we call it as methyl carbonyl. Now if you replace hydrogen with ethyl group, so now we have replaced a H with ethyl, therefore this compound is known as ethyl carbonyl. Hope you are able to understand the nomenclature. Now in the next case, let us replace two hydrogens. So here what we have done, one hydrogen is replaced with ethyl group, another one is replaced with the methyl group, then you call this as ethyl methyl carbonyl. Ethyl methyl carbonyl. Now suppose if both hydrogens are replaced with methyl groups. So this is another example where two hydrogens are replaced with the methyl group, then you call it as dimethyl carbonyl. Hope you are able to understand this. Suppose all the three hydrogens are replaced now with methyl group, then what do you call this? Because you have replaced with the three methyl groups, it will become trimethyl carbonyl. So now these are some examples. Let us take, if at all you are taking a bulky group. So this is carbonyl. In this carbonyl, if I replace one hydrogen with a bulky group, that is tertiary butyl. So I have replaced one hydrogen with the tertiary butyl group, therefore it will become tertiary butyl carbonyl. Fine. So this is about our first system of nomenclature of alcohols, that is taking the carbonyl, we have given the derivatives of carbonyl. Next one is common and IUPAC, wherein you are studying about monohydric, dihydric and trihydric alcohols. Monohydric, as you are aware, it contains one OH group, dihydric has two OH and trihydric has three OH groups. Let us discuss common and IUPAC nomenclature. Now let us write the common names as well as IUPAC names for these alcohols. Now first one, see CH3 group is methyl, so easily you can write it as methyl alcohol. First let us write the common names, then we will go to IUPAC name. Now C2H5 group is ethyl, so this comes as ethyl alcohol. Now next one is, see you have isopropyl alcohol. As you are aware, what is meant by iso? If you are having at second last carbon one group, then you call it as iso. So propyl, because three carbons are there. Next, coming to this, you have four carbons with OH. This one is written as N-butyl. In the previous classes, we discussed what is meant by N. N stands for normal, means a continuous chain. Next, here you can see that this is secondary carbon and OH is attached to this, so you can write it as secondary butyl alcohol. So why do you call it a secondary? Because you are having a secondary carbon to that, OH is attached, and 4 carbons but. Next, coming to this 3 and 4. So now this is again isobutyl alcohol. Why do you call it as isobutyl? Because to the second last carbon you are having a methyl group. Now this one you are familiar, a tertiary carbon. To that tertiary carbon, if OH is group is attached, then you call it as tertiary butyl alcohol. So these are the 7 monohydric alcohols, and we have written the common names. So if you want to write IUPAC name, let us see. Root word is meth because you are having 1 carbon. So let us write that, root word plus. If you are writing that primary suffix, then comes secondary suffix. As you are aware of this, what is primary suffix? That is nothing but if it is single bond in, double bond in, and triple bond is YNEI. Let us write this. First we take it as meth, single bond, therefore methane, and after this you need to remove this E and write the number first position. So methanol, either you can write a methanol or methane-1-ol. Now this one, numbering is taken from the side of OH, so you have 2 carbons, so root word will become eth, single bond, therefore ANE, and again 1. So we can take it as ethane-1-ol or ethanol. Now numbering from here, you have given second position, you are having OH, and the number of carbons are 3, so the root word is prop AN. As alcohol is at second position, we have written 2-ol. Coming to this 4 carbons, so the root word is but, primary suffix ANE, and at first position you are having OH, therefore butane-1-ol. Now numbering is given from this direction because OH should get the least number. If you give from this direction, it gets 3, and from here it gets 2. So 1, 2, 3, 4, root word is but, single bond AN, and at second position alcohol, therefore 2-ol. Now coming to this is the parent chain. Numbering is given from this direction. Now if you observe this, first position OL is there and second position methyl is there. Root word is prop due to 3 carbons, propane-1-ol, and second position you have methyl. So 2-methyl propane-1-ol. Now coming to the last one, you can take it as the longest chain. So numbering from here 1, 2, 3. So root word is prop, single bond ANE. Now second position OL, therefore 2-ol, and methyl is written as 2-methyl. Hope you have understood this. Writing IUPAC names, we have done a lot of practice. So we have completed the monohydric alcohols. Now let's move to dihydric and trihydric alcohols. Now let us see about dihydric alcohol, which contains 2 OH group, and trihydric alcohol, which contains 3 OH groups. See, commonly you call them as glycols, and here you can observe that there are 2 OH groups. Here also you have 2 OH groups. Now writing the common name is very simple. So this is ethylene group, therefore ethylene glycol. Now second one, propylene glycol. Then the third one, I can write like this. Now I'll take this. CH2 group is known as methylene, so we are aware of this. Methylene group. When we were talking about suppose for example homologous series, there we come across with the methylene group. How many are there? 3 are there. Therefore we can write it as trimethylene glycol. Depending upon the number of carbons, we have written like this. Now coming to the IUPAC names. So this is 1 and 2 and 2 alcohols, so therefore you call it as diol. It is the root word ANE. Try to understand that if there are more than 1 OH group, so you will retain E here. So ethane-1, 2 diol. Now coming to this, 3 carbons, give the numbering from here 1, 2, 3. So root word is prop, written E here, and 1, 2, 3 triol. 3 OH group, hence, sorry, 2 OH group, hence we call it as diol. Now coming to the last one, numbering from here 1, 2, 3 you can give. So root word will become prop, and ANE, because single bond are there, E you can retain. Now coming to this, the numbering here will become 1, 2, 3. 1, 2, 3 diol. See here the numbering was at 1 and 2. So it was 1, 2 diol. Now the numbering is at 1 and 3. Hence we write it as 1, 3 diol. Hope you are able to follow this. Coming to the last one, if you take trihydric alcohols, there are 3 OH groups, and we call this compound as glycerol. Giving the numbering, you can write like this 1, 2, 3. So root word is prop, ANE, 1, 2, 3 triol. Why you have taken tri here? Because there are 3 OH groups. Hope you have understood the nomenclature of alcohol, that is carbinol, common as well as iupacnates. Now let us see isomerism of alcohols. Now the next topic is isomerism of alcohols. See, you already know what is meant by an isomer. See, if you take 2 compounds which contains same molecular formula, they have same molecular formula, but they differ in structural arrangement. They differ in structural arrangement. Then those isomers are known as structural isomers, and the phenomenon is called structural isomerism. So in alcohols we find 3 types, that is chain isomerism, position isomerism, and then functional isomerism. These are related to the structural isomerism, and the 4th one is optical isomerism. So we need to discuss about these 4 types of isomerism. So let us take first one, that is chain isomerism. See, it will indicate us what is the difference in this. They have same molecular formula. The 2 compounds will have same molecular formula, but different arrangement of carbon chain. Different arrangement of carbon chain. So let us take, see, for 4 or more number of carbons this is applicable. So taking like this, now we have butane dash 1. So this how you can change. One group can be changed to like this. We can write CH3 here. Now what happened? We have changed the carbon chain from 4 to 3. Now this is a branch here. If you observe what is the molecular formula of this, so C4H10 5 C4H10O. Here also the molecular formula will remain the same, C4H10O. Now coming to the nomenclature, 1, 2 and 3. Now propane dash 1 ol, but at second position you are having methyl group. We can say that these 2 are considered to be the chain isomers, and the phenomenon is called as chain isomerism. Hope you have understood this 4 carbon chain, but here you are having only 3 carbon chain. Second one is position isomerism. The name itself says that you are changing the position of functional group. We can write like this. What is the definition? The compounds which are having same molecular formula but different position of functional group. Different position of functional group. They are called as position isomers, and the phenomenon is called position isomerism. Let us write like this. Either you can take it as 3 carbon chain, or you can take it as 4 carbon chain also. Here we have propane dash 1-ol. So this is nothing but propane dash 1-ol. Now if you change the position of OH to the second carbon, we can write like this. It will become propane dash 2-ol. Hope you have understood this. What we have done, from first carbon we have changed the functional group to the second carbon. But if you observe the molecular formula, it is nothing but C3 578H8O. Here also the molecular formula is C3H8O. What you observe here, the two compounds are having same molecular formula, but what is the difference here? Here OH is at first carbon, here OH is at second carbon, hence you call them as position isomers. Coming to the second example, we have taken at first position, hence due to 4 carbons of butane, first position oil, butanol. Now coming to the molecular formula, C4H10O. So next one, by changing the position at a second carbon, so we can write like this. This is known as butane dash 2-ol. Now calculate the molecular formula. It is nothing but C4H10O. We can say that these two compounds will have same molecular formula, but the difference in the position of functional group. Hope you have understood the chain isomerism as well as position isomerism. Now let us see the last two types of isomers. Now let's discuss about the third type, that is functional isomerism. So here we can say that the two compounds with the same molecular formula, but they are having different functional groups. See, earlier in the position you had same functional group OH, but here you should have different functional groups. See, we are aware of that. If there is an alcohol, its functional isomer will be ether. If you are having carboxylic acid, it is ester. If it is aldehyde, its functional isomer will be keto. This already we have discussed. Now because we are studying about alcohols, let us take the example. Here we have 3 carbons, propane dash 1-ol. We can also take 4 carbons, butane dash 1-ol. Now we have alcohol here. By changing this into ether, so how do you write? 3 carbons are there. So I will write like this: 1 carbon here and the remaining 2 CH2 and CH3. Fine. And according to the nomenclature of ethers, later we will discuss that this is nothing but a methoxy. Always oxygen is given to the less number of carbons, so we call it as methoxy. Root word is eth because you have 2 carbons. Single bond, therefore Ane, methoxy ethane. Now coming to the next one, so we will take it as 4. So let us write like this: CH3 CH2 and CH2 CH3. Hope you have understood this, because in the first case you have 3 carbons, we have written 1 and 2. Here you are having 4 carbons, so you write it as 2 and 2, or 1 and you can also write 3 also. So this can also be written like this: CH3 dash O, CH2, CH2 and CH3. So these two can be taken. Now if you write this, we call it as ethoxyethane. Hope you are able to understand this. Now in this case, methoxypropane. In this condition, if you calculate the molecular formula, what you get? 3 carbons, C3H8O, and here also you will get C3H8O, 6, 7, 8, 9. So same molecular formula, but what is the difference? Here the functional group is alcohol and here the functional group is ether. So hence you call them as functional isomers, and the phenomenon is called functional isomerism. Coming to this, you C4H10O is the molecular formula. Here you can calculate, again you will get C4H10O. Here also the molecular formula is C4H10O. Hope you are able to understand this. This is about the functional isomerism of alcohol. Now the last one is optical isomerism. The last one, that is optical isomerism. See, we have already discussed that there are two types, that is dextrorotatory and levorotatory. So in the previous classes we already know. Now let us see in the alcohol what are the two examples. We take first, we can write it as butane-2O. So in this we can take alcohol here, and here we can take CH3, and we can write C2H5, or you can take CH2. Hope you are able to understand this. We have written OH on the right hand side. Now this will exhibit dextrorotatory nature. Dextrorotatory nature. That means if you take this compound and pass it through the optical rotatory light, then you can get the light, that is plane polarized light, will rotate towards the right side or clockwise. Now we can say that small d, that means dextrorotatory compound. But if you observe the molecular formula, you have C4H10O. Now coming to the next one. So what is done here? The OH group is written on the LHS. So this will exhibit levorotatory nature. That means the plane polarized light is rotated towards left or anti-clockwise. So I can write small l butane-2O. Coming to the molecular formula, once again you will get C4H10O. So what is the nature of this? The nature of these two compounds are different. What are that? They have same molecular formula, but this compound will rotate plane polarized light towards clockwise, and this compound will rotate the plane polarized light towards anti-clockwise direction. Hence we have written D here, and here it is L. So this is an example given for optical isomerism. Hope you have understood this. In this lecture we have discussed the nomenclature and isomerism of alcohols. Thank you so much.